However, not everything. If you click it, you will see all the schedule and plan and materials. So the first week we have, I'm going to talk about op-amps and the circuit design schematic. And next week you come to the lab, and there's no lecture next week. Directly get into the lab and work on your circuits. So I think the capacity of the two room, 204 and 205, 304 and 305, can only host like 50 people in there at the same time. So you can go there anytime during the week to build your circuits, not just during the lab time. But the thing is, I will be there, and the 3 lab assistants will be there to help you out during the lab time. We have a slides from Dr. Costin. I modified it a little bit, adjusted a little bit. And here's the homework assignments. It's just questions, okay, questions. And I think it's 176 points. So for the problems, the questions are about 76 points. And the number 10 is a video submission. So every one of you should, not everyone, because we are forming teams, right? So it's 2 students, 2 people on a team is allowed. But every single student has to submit their own reports. You can share figures, videos, however, it's going to be individual reports. You know what I mean? Okay? The link could be the same link. For example, you worked on the circuit, you got one demonstration video. You submit it to one YouTube channel, it's okay. However, you have to draft your own reports and put a link into the report and submit it. It's your individual, it's your own assignment to be submitted. So that's number 10. So since the grader probably won't be there physically during the lab, so we want to be really clear during the demonstration, tell what you have done in the lab, not just being silent and just get an LED blinking, nobody knows what you did, right? So just talk about it a little bit, do the demonstration and show so the TA can grade it. Okay, any questions by far? Any questions? Is that clear? Because it's just 1 credit. I think it's, the workload is lighter than 3 credit class. We only have 1 session a week. But it's quite useful. I'm pretty sure it's going to be probably one of the most useful classes you have taken, you know, for job interview when you're in your senior year. I do just ask about PCB questions. You know, this is something has been happening for my students at Ford. It's just all about because I can tell if you are a fake engineer or not just by 3 questions. Okay? If I ask you, do you know 0603? You say, what is that? 0805, what is that? Okay. If you have soldered even just 1 PCB, you will be able to know. However, you have never done that. You are grabbing someone else's PCB to show it during the interview. Okay? We'll find out. So it's a useful class. You guys, you know, are lucky to have this PCB class, a dedicated PCB class in your curriculum. It's great. Okay, let's talk about the circuit design. Circuit design. I usually don't use slides, but let's use it. So the link is available on my website. You know, it's just I think the name of the circuit is called the VU meter. It's a volume unit meter. It's showing a LED depending on the volume of the voice or signal. So how that works? Have you used the potentiometer before? Yes, easy, right? Just a pot. And what about op-amp? Yeah? Okay. So we don't have, the lab coordinator just told me this morning, we don't have LM324, like what Dr. Carlson put on the website. So instead, we have TLC274. It's okay, just op-amp. I've never used it, but it's okay. I know how to use it. How many terminals?
Is this information stated somewhere on your website where
Yeah.
we're not using
Yeah,
it?
let me show you.
Beautiful.
Good question. What's that?
Beautiful.
Okay. So this is the website, right?
Okay.
So you got into my main page. What's the domain name? Quiz 1. What's the domain name? Electronics.com. What's the course name? You know that. Click 393. Click 393. You can get to the web page, has all the information. And we're just using Dr. Carlson's website as a reference. Okay, so this will be the main page. Dr. Carlson's webpage will be a reference. So come to this webpage to give you everything, almost everything, including the link to Dr. Carlson's class. And homework 1 is here, right? So you can click to get homework 1. Slides, the OPAM datasheet. Schedule. So here's OPAM. OPAM has power supply, VSS, VM, VP, and output. Okay? If you don't give a feedback to the OPAM, no feedback. So what is the OPAMs being used for?
Comparators.
Yeah, comparators. So why we can use as a comparator? What's the answer?
Because their gain is so large that if there's any positive difference between the two terminals, then the gain is so large that it just hits the supply rail of the op amp.
Yeah, but what's the parameter determines that? What's the parameter of the op-amp determines that behavior? This could be an interview question. Seriously.
The open loop gain.
Infinite open loop gain. Because the infinite, usually like millions of times of gain. Alright? But if you give a feedback, are you still having that infinite open loop gain? You still have it across the terminals, but however the input and output will be changed. You are having a finite closed loop gain determined by the resistor ratios. Okay? And so for this time, we are using this op-amp as a comparator. Let's take a look at schematic. So go to Dr. Carlson's website, lab 1. So here's the schematic. Circuit 101. Okay. This is a comparator, right? How to tell is a comparator? Yeah, open loop, no feedback, right? No feedback. Did you see a feedback from the output to input? No. So it's a comparator. So potentiometer is on the top. Okay? So the resistor string is doing what? What's the resistor string is doing here? So what's the input resistance of the op-amp? Infinite. Any current flowing into it? No. So the resistor string here is being used as what? Voltage dividers. So it's dividing the voltage source. So the first time I heard about the op-amp is not available, and we have this thing available here. So what's the first thing you want to look at? You got a new op-amp. What's the first thing you want to look at? Gain. Yeah, we are using the infinite open loop gain. So usually, as long as they are being sold by a decent company, it should be infinite open loop gain. That's one of those things we want to look at as well. That's right. But here for this lab specific,
How many op-amps are on the chip?
that's another thing we want to look at. That's good. Yeah. Anything else? Voltage ratings. Okay. So what's the power supply you want to use for the op-amp? What's the voltage here? Can you see? Is it 5 volts? VDD 5 volts. So after I see that, I was like, good. Don't have to get a regulator for it. Okay, it's gonna work. Resistor string, 10K resistors. Why not 10?
Because then you'd have too much current.
Too much current. Okay, so 10 ohms. 10 ohms is a heavy load or light load. What about 10K? So 10K compared to 10, which one is a heavy load?
10 ohms is basically 0.
10 ohms is going to draw a lot of current. It's difficult to drive. 10K is an easy load. 10 mega ohms is even easier. Okay, keep in mind. Low resistance will be a heavy load. Heavy load, not resistor, load. Okay? Keep in mind, okay? Important and basic concepts. So the voltage being divided, you are getting different voltages at different points. So stepping down the voltage source to lower voltages. If I draw if you have questions, feel free to ask during the lecture. Okay, no worries. Because a lot of times the people sitting in the front are usually, have a lot of experience with circuits. I'm serving 100 students, not just 2. Okay, feel free to ask questions anytime. No question are stupid questions. Anytime, emails, anything. So you guys are here to learn how to make PCBs. You are not supposed to know it before you come to this class, right? Okay? Let me slow down a little bit. If I keep this guy open loop, I label this point as VP, VM, V positive and V minus, V plus and V minus. Here's V out. So V out equals what?
Plus minus V minus times open loop gain, which is infinity.
Yeah? So A is the gain, right? So AOL is open loop gain. VP minus VM. This is a non-inverting terminal minus inverting terminal, and times the open loop gain will be VL. And because this guy is so big, whenever you have a little change, it's going to saturate the output to where? Yeah, to the rails. Who said the rails? These are the rails, right? Power rails. Okay? VDD, VSS. Usually what we do with the VSS for op amps. What we do with it. We ground it. Sometimes on the textbook, you put a minus voltage into it. Why do we do that?
If you put a minus voltage into it, then you don't have to bias your input signal.
Yeah. So it's going to swing around. Swing around what? 0. Okay? Let's just consider, it's something else we can talk about later, but for now we ground it because it's going to be a digital circuit. Digital circuit doesn't have any negative voltages, right? Digital circuits, you have learned logic, right? Digital logic, 1 and zeros. There's no negative ones, right? 1 and zeros. So comparator is providing a digital output, 1 and zeros. As a comparator, how that works. I'm going to explain that now, since I know a lot of people already know how to do it, how this works. But I believe 90 out of 96 probably you don't know how to use it. Now let's get into it. So here's the op amp, has 1, 2, 3, 4, 5 terminals. Okay, it's exactly the same number of terminals as the op amp we're going to use. So the chip has 4 op amps on the chip. And we saw 4 on the schematic. We only need how many chips? 1. Because the 1 chip has 4 op amps. Okay? And VP minus VM times this will saturate it. So if we give VM a voltage, we call it ref. It's a reference voltage, doesn't matter, it's just a DC voltage. Okay? VM is connected to VREF. Keep in mind, VM is connected to VREF for this example, for now. Let's say 1.2 volts, 1.25 volts, I'm sorry, 1.25 volts. That's Vref, which is what? Vm, which is a terminal connected to the inverting terminal of the op amp. I'm giving a sine wave, something like a sine wave, to Vp. What's going to happen to V out? It's going to be a digital signal, right? So so here Vp is lower than Vref, you plug into this equation, what's going to happen? Vp is lower, so Vp minus Vm is a negative number, right? But do you have a negative number in the real? No. So the lowest voltage you have is 0. What's going to happen? It's going to saturate. It's going to saturate at 0 volts. So whenever Vp is lower than Vm, what's going to happen?
0.
Yeah, so here will be 0 volts. Your power reels, what's that?
But you can't switch in 0 time.
You mean here?
Yeah, you can't change in 0 amount of time. You can't go directly between 2.
Yeah, there will be a ramp, right? But because it's so fast, and why it's so fast? That's another, this is a good question actually. Why it's so fast? Why is switching so fast? Why is switching so fast?
Because of the high gain.
Yeah, with a high open loop gain. So strong. It just want to pull it up so quickly. But is it infinite? No. Definitely it's charging up the caps. It's charging up all the parasitic capacitance in the circuits. It takes a finite amount of time. So it's going to rise to where? So when Vp is larger than, even just slightly larger than Vm, you are getting a little tiny positive number. It's okay. So you have a huge open loop gain. Times this number will burn it up to a big number, which is even larger than 5. If you are supplying a 5 volts to it, it's going to saturate the power, the output immediately. It won't go to 1,000 volts since you don't have 1,000 volts supplied to the circuit. It's going to saturate at 5 volts. So what's going to happen is it's going to hit 5 volts very quickly and stay there until here. It's going to do this. Okay? If I swap these 2 points, you should be able to know how to do it as well. Usually I'm going to give you a quiz on this, but actually every time I give a quiz, the grader has to grade it for like 8 hours for 100 students. All right. But you know how to deal with it, right? If I swap it, what's going to happen? Okay? And now let's take a look at it. All right. Where is the reference voltage? What is the reference voltage? So which point is connected to the reference?
The voltage divider.
Voltage divider, why? You don't want to change the reference, right? If you change the reference, it's not a reference anymore. Okay? So it's all static DC voltage across the divider. It's supplying DC volts to the op amps, and you are twisting that little potential meter to look at the little LEDs changing, you know, like a VU volume unit. So if you change the voltage of the potential meter, it's going to change the LEDs. Which one will be light up, which one's not, okay? So you guys are familiar with LEDs, right? LEDs, it's an anode cathode, it's a PN junction. So current only flows in one direction. And this is, 10K. I've never used anything more than 1K for LEDs. So probably it's trying to dim it anyway. So Usually I use 300 to 1K up to 1K. Anything larger than 1K will dim it significantly. But 10K, I don't know, try it. If it doesn't work, you can switch to a lower resistance. So what's the name of the resistor over here? What's the name of it usually? Oh, what is this resistor doing? Current limiting. So it's a current limiting resistor. Because the internal resistance of the diode is really tiny, it's small. So when you directly connect to the power supply, and it's going to draw a lot of current. Okay, so whenever the diode has a low internal resistance, is it heavy load or a light load? Heavy load, right? Because low resistance will draw a lot of current. So it's the heavy load. And you don't want to directly connect to power supply because low resistance draw a lot of current, probably will blow it up before you want to use it for any purposes. It's going to reduce the lifespan a lot. Or anything usually lower than 300 ohms will reduce the lifespan of the LEDs. So usually 300 ohms and up. But 10K will be a little bit too big. I've never used that for a current limiting resistor for LEDs. Just to let you guys know, if it doesn't work, switch to lower ones, okay? And resistor values, the color bands. Oh, we don't have, because including the embedded system lab, there are 2 labs, in-lab and lab. I'm putting everything in one because I think it's doable. Probably you spend like 3 hours in the lab and another like 1-2 hours after the lab, you'll get everything done. I don't want to make it too long. And as long as I can learn the essential stuff over here. And also I have all the questions. Sorry. Electronics.com. So that's the only assignment you are turning in every week. It's really clear. I have everything listed in the homework. Bullet points, 1, 2, 3, 4, okay? Just work on that one, get everything done. You'll be fine. One task, one assignment every week. Okay, make it easy for the grader. Am I missing anything? Let me see. Do you have any questions on anything?
Yes.
What's that?
So I see next week is no lecture, we'll be in the labs.
Yeah.
And is that how it's going to be shown in the future on the notes? That way we know when we need to be in here versus in the lab. How will it be shown? Because right now I see lecture in Hill Hall.
Yeah.
And then the rest are blank. How will it be?
Yeah, there will be 3 lectures we have to do in Hill Hall because that was the original assignment, the assigned classroom. Because we are considering like it's already late night, don't want you guys walking on campus. So it's shorter distance from here to the lab. Okay, so you guys take a lecture here and go to the lab. That's why we switch it to this room.
For next week, if I have a ton of energy and motivation to do the lab before the 6 to 9 period, do I have to show up at all?
No, I'm not counting attendance. As long as I can get things done.
Does that mean the class schedule will always be lecture and then you can just go to lab? Is that
Yes.
how it'll be structured?
Yeah, and I actually asked a lab coordinator today because we don't have the capacity to host everybody over there. But likely in the future, we're just using laptops. So you can stay anywhere in the, probably next to the lab because I will be there and the lab assistant will be there, can help you guys out. If you think you don't need help or you need more room, you can stay here. But when you have questions, you can just go to my office or the lab room to ask questions.
Where's your office? Are you in Colson's office?
Yes, the office is just in the office hallway. It's close to other people's offices.
Free office areas?
Yeah.
Okay, the newer one. I got
Are
it.
you near Dr. Owen?
Oh, I don't know him actually.
Is that the kitchen?
Oh, the kitchen. Yes, the kitchen. Yeah.
Oh, so okay.
Actually, I will be in the lab because this is just one section. Just one section. I will be in the lab. Yeah, there will be like 50 students over there, hopefully, and I will be there.
What should we expect turnaround time on homework to be?
Turn on time. What do you mean? Oh, what do you
Like,
mean?
I turn in my assignment, when do I get it graded?
Oh. We'll see
Day,
the
a week,
schedule.
a month, a year?
I think a week, 2 weeks, no
Okay.
more than 2 weeks. I think.
That's great.
That's great. Okay.
Yeah, that's much
Depending-
better than some classes from last semester.
Oh. Okay. Cool. I'll see if the grader can do it. Any other questions?
So you said the cards we need aren't yet available. Do you know when they'll be available for us to use?
I probably will send an announcement to Canvas. No later than next Monday, because Monday will be the lab time officially. That's what the department plan on. If it becomes available earlier than that, I'll let you guys know. But plan on doing that next Monday. It's just one more work, right? You guys are students at mines. Do you want to do more work? No, thank you. Okay. So just wait until next Monday. Just expect the next Monday to start the first lab.
So, outside of homeworks,
Yeah.
what other grades exist in this class? Do we have any types of projects or exams or anything, or is it just homework assignments as we go in?
I don't think there are exams. It's just the homework assignments plus a. I don't know yet. I have to ask Dr. Carlson. I'm not planning on having any exams, unless he tells me we have to. There probably will be a final project for you guys to have more fun. Anything else? But even we don't have labs this week, you can still work on homework 1, right? So look at the resistor colors. Are you familiar with the colors, the color band of the resistors? Okay. If you read through the Dr. Kelston's website, you should be able to understand what's going on easily. Let me ask you guys, what brown stands for? Brown. Brown, B-R-O-W, and brown, the color in the resistor band, color band. 1, yes. Black. 0. Red. 2. You don't have to be in this class, I think. You guys are so good. Okay? Other people who are not familiar with the color bands of the resistors, study it. You have to because it's in homework 1. Just study it. It's okay if you don't know it now. It's okay. All right? Study that. It's easy. It's easy. Anything else we have? Let me skim through his lab 1 really quick. Oh, actually, no. You know, since we are homework 1 is the only thing we have, right? Let's see. Color bands, package, voltage dividers, potential meters, comparator. Easy. However, if you are not familiar with the contents, feel free to email me anytime. Office hours are Monday, Wednesday, Friday, 8 to 9:30 a.m. But you can also you can always email me to ask questions as well.
I'm still a little confused about the lab versus in-lab thing. So are we doing?
That's not this class.
That's not this. Wait.
Yeah, just one lab. Don't worry about the in-lab. Since I already took whatever in the in-lab and the lab and combined them together as one lab.
Gotcha. So we're like.
For embedded, not for this class.
Both. Yeah.
Great. So is there a different document that combines both of them, or do I just?
Yeah. See, everything will be on the website. I'm going to post a link and all the instructions over here. All right. That's it for today. If you don't have any further questions.